Hello, my name is Walter Unglob, and this is the physics of wheels rolling. So here we're going to consider a wheel that's rolling on the ground, and it's rolling without slipping. What that means is that this point of the wheel stays and remains in contact with the same point in the ground. The wheel does not slip. So, in considering a rolling wheel, there's two types of kinetic energy that we have to consider. There is the translational kinetic energy, which is given by your standard 1/2 mv squared, where m is the mass of the wheel, and this velocity is the center of mass velocity of the wheel as it just moves across space. But because it's rolling, it will also have a rotational kinetic energy. So this kinetic energy will be equal to 1/2 times the moment of inertia times the angular velocity squared. Now the linear velocity and the angular velocity are related in this fashion, where v is equal to omega times r, and r is the radius of the wheel. So, if we're considering rolling without slipping, then we want to add these two energies to get the total kinetic energy, but we also want to understand the relative velocities of the mass at different points along this wheel. So in the case of translational kinetic energy, we have a wheel that's moving from left to right, and it will be moving with a velocity v. So each of these 3 points is moving at the same velocity, but we also have to add the result of the rotational kinetic energy. So here we have this point on top of the wheel moving in this direction, but the mass on this end of the wheel is moving in the opposite direction because it's rotating, and there is zero velocity in this rotational frame for the center. When we add up these velocity vectors, we see that at the top we actually get twice the velocity of the center of mass. At the center, we just have our normal velocity, but we see that at the bottom, these two velocities cancel out. So, when the wheel is rolling without slipping, the bottom part of the wheel actually isn't moving, and the top part of the wheel is moving at twice the velocity as the center of mass of the wheel. Finally, this inertia for the rotational motion is given as the mass of the wheel times the radius squared. My name is Walter Unglob, and this is the physics of wheels rolling.